welcome to a very special mini-series of Biology Explained with me, Mr. Hill. In this short series of 4 episodes, we are going to be exploring some of the numeracy skills that you need in order to ace your National 5 Biology exams here in Scotland. Now, time and again, my students are dropping the odd mark here or there for simple mistakes when it comes to applying basic numeracy skills to data in questions. Typically, students will be asked to calculate ratios, percentage changes, averages, and converting units. And so over the course of these next 4 mini episodes, we're going to explore how it is that you do these calculations. Now, as always, if you do enjoy these videos, please do like and subscribe so you never miss a future episode. And indeed, Season 2 for Unit 2 of National 5 will be coming live in the next few weeks. So please don't miss out. Okay, so for this episode, we're going to begin with probably the most basic of calculations you're expected to do, and that is calculating an average. So tune in, make some notes, practice the questions at the end, and I do hope you can improve your confidence on calculating averages in National 5 Biology.
So calculating an average couldn't be any easier. This is something that we do a lot in biology and indeed all the sciences, and it would have been something that you would have come across in maths. Now, technically, an average is a family of calculations that you could do. These include the mean, the median, and the mode. But in science at National 5 level, all we're concerned with is looking at the mean, which is your sort of typical average that you might calculate. Now, it really is a very simple calculation. All you are going to have to do is to add up all the values that you have and divide it by the number of values that you have collected. So in the example that we're going to run now, you can see that we have 3 different beakers with different numbers of stars, and we want to calculate the average number of stars per beaker. So quite simply, you need to count up the stars in each beaker, add them all up, and because there are 3 beakers, divide that beaker number by 3 to give us our average. So if we go ahead and look at these blue numbers, blue stars, you can see that we have 1, 2, 3, 4, 5, 6 stars in our beaker here. So I'm going to put 6 in the post-it there. Beaker number 2 has 4 stars, and beaker number 3 has 2, 4, 6, 8 yellow stars. So we're going to add all those up together. 6 plus 4 plus 8 is going to give us 18. And because there are 3 jars, 3 beakers, we're going to divide that number by 3. 18 divided by 3 is going to give us 6. And so our average number of stars per beaker is 6. Nice and simple. Okay, all you have to do is add up your values and divide by the number of values that you have. Now, this is very critical in science because whenever you do an experiment, you are probably going to be doing it more than once. This is because every time you run an experiment, you're going to get a slightly different result. And so to ensure that your experiment is reliable, you're going to repeat it, and then you're going to calculate the typical value that you would have got after all of your experiments. This improves the reliability, and it's a very important scientific skill that you have to deploy in any type of experiment that you do. Okay, so now you've seen how to calculate an average, it's now your turn to have a practice. So on the screen, you can see a table with 3 different sets of data. Samples A and B have got 4 sets of data, and question C there has 3 sets of data. What I'd like you to do is to have a go at calculating these averages, remembering that all you have to do is add up the values and divide by the number of values that are there. So pause the video, grab yourself a calculator, and when you're ready, we can look at the answers. I hope that was successful for you. I hope you were able to calculate these averages successfully. We're going to run through the calculator now on the screen just to be sure that we're doing it correctly. And we're also going to have a couple of comments on the number of decimal points you should be using in your answers. And this is related to something known as significant figures, which we'll talk a little bit about as we go through the answers. Okay, so for question A then, you've got 4 samples and the numbers were 45. So let's put this into our calculator. 47, so you add those together, add 32, and add 55. This is going to give us a total of 179. We're then going to divide this number by 4 because there are 4 samples, and that's going to give us 44.75. Now, if you look at the question A, you can see that all the numbers have 2 numbers to them, 2 digits to them. Okay, this is these numbers are at 2 significant figures. So it's important that our answer is also at 2 significant figures because your average can't be any more specific than the numbers that you have recorded in your experiment. Okay, this is to do with the resolution of the equipment that you're using to measure your outcomes. Okay, so it's important that you don't use too many decimal points, and you should keep the significant figures equal to the values that are already in the table. So in this example, we're going to stick it to 2 significant figures, which means we're going to round this up to 45. So the average here is 45 for question A. So for question B, we'll do the same. We've got 4 values as well. Let me clear the calculator. So it's 1.1 plus 0.7 plus 2.1 plus 1.8, which gives us 5.7. There are 4 values. So we're going to divide that by 4, and that gives us a value of 1.425. Now, once again, it's unlikely that our measurements in this experiment will be able to measure something as specific as 1.425. Instead, we're going to have to keep this to the same significant figures that our values already are at in the table. So we're going to keep this to 2 signifig, because you can see that the samples there, 1, 3, and 4 at least, have 2 significant figures. So we're going to keep it to 2, which means we're going to have to round this down to 1.4. So the answer, the average here, is 1.4. Remember, your decimal points should essentially match those of the samples already in the table. Last but not least, we've got sample set C. So let me cancel our calculator and add these numbers together. So we've got 65.8, we've got 78.1, and we've got 99.2. The total there is 243.0999999. Okay, so we're then going to divide that by 3, because there are only 3 values in this sample set. And that gives us a final total of 81.033333. So again, we've got 3 significant figures here this time in all our sample numbers. So we're going to make sure that our average is also to 3 significant figures. So it's going to be 81.0. Okay, the 0 is still a significant figure because it's following numbers of value there. Okay, so I hope that was useful. I hope you were able to calculate these successfully. Remember, the averages, all you need to do is add up those values and divide by the total number of values.
So there you have it, how to calculate an average in biology. All you need to do is to add up all your values and divide it by the number of values that you have, and then you've got yourself your average. I hope that was useful. Please tune in for the next episode, like and subscribe so you don't miss it, and I hope to see you again very soon. Cheers now, bye-bye.